For many years, people have looked up at the sky and noticed a bright red star called Betelgeuse. It's one of the largest and brightest stars visible without a telescope. Betelgeuse is found in the Orion constellation, shaped like a hunter. This star is classified as a red supergiant, meaning it is much bigger and older than our Sun. In fact, Betelgeuse is so huge that if it replaced the Sun, it would stretch all the way to Jupiter. That means it is over 1,000 times wider than the Sun. It would cover the orbits of Mercury, Venus, Earth, Mars, and more. Recently, scientists noticed something strange happening to this massive star. Its brightness started fading quickly, and no one knew why. This unusual dimming made many wonder if Betelgeuse was about to explode. Stars like Betelgeuse usually end their lives in a massive explosion called a supernova. A supernova is one of the most powerful events in the universe. If Betelgeuse went supernova, it would be bright enough to see during the day from Earth. Some believed it could shine as bright as a full moon in the night sky. But after months passed, Betelgeuse didn't explode. It stayed dim for a while and then got a little brighter again, confusing many astronomers. That's when the world turned to the most advanced space telescope ever built, the James Webb Space Telescope, JWST. JWST is designed to look deeper into space than any telescope before it. It uses infrared light, which allows it to see things hidden from normal telescopes. Infrared light lets JWST see through dust and gases that block our view in space. This makes JWST perfect for studying stars like Betelgeuse. When scientists pointed JWST at Betelgeuse, they hoped to discover what was really going on. The images JWST sent back were amazing and changed what we thought we knew. The surface of the star looked wild, full of hot spots, dark patches, and giant storms. It wasn't a smooth glowing ball like the Sun in pictures. The star was boiling with activity, and something dramatic had clearly happened. Scientists now believe Betelgeuse had a huge eruption, like a starquake. This eruption might have thrown out a massive cloud of gas and dust. That cloud could be why we saw the star dim from Earth. The cloud acted like a veil, blocking some of the light from reaching us. This shows the situation is much more complex than expected. We still have a lot to learn about how stars behave near the end of their lives. What surprised researchers most was how unpredictable Betelgeuse turned out to be. We used to think we could tell when a star was about to explode by watching its light. But Betelgeuse shows stars might have many strange events before they go supernova. This makes it harder to predict when the explosion will happen. But it also makes it more exciting, because anything could happen next. Some scientists now think Betelgeuse could explode tomorrow or not for another 100,000 years. Even though we don't know when, we do know it will be an amazing event when it happens. A supernova this close would let us study the process in real time. We could learn how the explosion spreads, how elements are created, and how new stars are born. That's right, supernovas create the ingredients for new stars, planets, and even life. The iron in your blood and the oxygen you breathe were once part of a star that exploded long ago. In a way, we are all made of star stuff. Remains of ancient stars that lived and died billions of years ago. This is why scientists are so excited about Betelgeuse. It's not just about watching a star, it's about understanding our own origins. The James Webb Telescope is helping us answer some of the biggest questions about the universe. It was launched to look deep into the past, even to the first galaxies that formed after the Big Bang. But it can also help us understand things much closer to home, like Betelgeuse. Thanks to its powerful mirrors and sensors, JWST can see details other telescopes miss. It can spot changes in a star's atmosphere and even track how it moves and pulses. Betelgeuse is now under constant watch as we wait for more signs of what it might do next. With each new image, we're getting closer to solving the mystery of this giant star's behavior. But Betelgeuse isn't the only star JWST is looking at. It's also searching for other supergiants, strange stars, and even planets beyond our solar system. These planets, called exoplanets, might one day show signs of life. By studying how stars die and form, we can learn where life might begin. So while we wait for Betelgeuse to possibly explode, discoveries continue. Each new picture from JWST gives us a better view of the universe's secrets. Even stars that seem familiar can surprise us with something completely new. This is just one example of how the James Webb Space Telescope is rewriting our understanding of the cosmos. Betelgeuse, once just a bright dot in the sky, has become one of the most important stars in science today. If it goes supernova in our lifetime, we'll get a front row seat to one of the greatest shows in space. But even if it doesn't explode soon, what we're learning is already changing astronomy forever. It's a reminder that the universe is full of wonders we're only just beginning to explore. Thanks to tools like JWST, we're more prepared than ever to discover them. As the James Webb Telescope continues to study Betelgeuse, scientists have made even more interesting discoveries. They found signs that the star was pulsating, getting slightly larger and smaller over time. These pulses can cause shock waves inside the star, leading to giant surface eruptions. It's like the star is breathing, slowly expanding and contracting as it ages. Each pulse tells us something about what's happening deep inside the star. With JWST's precise instruments, scientists measured changes in temperature and movement across the surface. They noticed parts of Betelgeuse were cooling rapidly, while others were heating up. This imbalance is unusual and might mean the star's core is unstable. When a red supergiant like Betelgeuse becomes unstable, it usually means it's close to the end of its life. Inside the core, heavy elements fuse in layers. Hydrogen turns to helium, then carbon, oxygen, and even iron. Once a star starts making iron, it's a sign it's running out of fuel. Iron doesn't release energy when it fuses, so the star can't support its own weight anymore. Eventually, the core collapses and the outer layers explode in a supernova. JWST is watching these changes closely to see how fast this process happens. Betelgeuse gives us a rare chance to study a star nearing its death while it's still alive. This helps scientists prepare for other supernovas that might happen farther away. It's not just about looking at one star. JWST's findings help us understand how all stars die. Each image and data point adds to our understanding of stellar life cycles. What's amazing is that this information helps improve our models of the early universe. When the first stars exploded, they created the elements that formed everything we know. By watching Betelgeuse, we're really looking at a mirror of the past. It's like seeing history happen in real time, from billions of years ago to today. The James Webb Space Telescope is also helping answer other questions. Why do some stars explode in certain ways while others just fade out? What happens to the core that's left behind? Sometimes, a star's core becomes a neutron star, an object so dense a spoonful would weigh millions of tons. Other times, the core collapses into a black hole, sucking in everything nearby with its strong gravity. Scientists hope that by watching Betelgeuse, they can tell which fate awaits it. This could be the first time we watch a star explode and then see what it becomes afterward. Betelgeuse is close enough that JWST and other telescopes can study it in great detail. If it explodes in our lifetime, we'll have the best view ever recorded. This explosion will send out waves of light, energy, and matter. JWST can capture it all across different wavelengths, from infrared to visible light. Other telescopes on Earth will join in, creating a worldwide effort to watch this event. This teamwork between space and ground telescopes has never happened before in such detail. It's like preparing for the greatest science event of the century. But even without the explosion, Betelgeuse is teaching us more than expected. It reminds us that stars are not simple. They are complex and changing all the time. Stars don't just shine quietly for billions of years and then explode. They wobble, pulse, erupt, and shift, giving us clues about their inner workings. This changes how we write our science books and understand the stars in our sky. Thanks to the James Webb Telescope, we can now see these things clearly and up close. It's like getting a telescope that lets us see behind the curtain of space. Betelgeuse is just the beginning. JWST is looking at many other stars too. Each one may have its own story, secrets, and surprises. One day, JWST may even help us see a supernova from the very first moment it begins. This has never been done before and could answer some of the biggest mysteries in science. How long does it take for a star to go from collapse to explosion? What happens in the exact second the core gives out? These are things we've only guessed before, but now we might actually see them happen. This is why scientists are excited about Betelgeuse, and why you should be too. It's not just another star. It's a living lab. A mystery unfolding in the night sky. JWST is our window into that mystery, showing us what no one has ever seen. As we watch Betelgeuse change, we're learning more about ourselves too. Because the atoms in our bodies were made in stars just like this. We're connected to the universe in ways we're only just beginning to understand. Every photo from JWST brings us closer to answers about where we come from. It's not just about science. It's about our place in the cosmos. That's why this story matters. And why Betelgeuse is a star worth watching. Subscribe to our channel and thanks for watching.